Hello everyone, I'm Mert Karaoglan. Today I'll be presenting powder bed processes. Let's look at the general logic here. The process utilizes a scanning mirror to direct a laser source here, as you can see. As the power quasar spreads a layer, the build station pistons lowers precisely. Notice the loose powder in engineering terms. This provides natural structural support for the part during the build. Successful manufacturing requires controlling at four values. First of these is moisture for flowability. The second one is particle size for density, and the third one is thermal management to minimize residual stresses. And then the last one is shielding gases like argon to prevent oxidation or explosion. Let's look at the CLC. CLC is the standard for polymers. It's used a dual cylinder mechanism, as you can see here, one for supply and the other one for the build is using. The unfused powder bed eliminates the need for complex support geometries, which has significant advantages for intricate designs. CLC is versatile handling polymers, wax, and the ceramics with a tolerance of like 0.1 mm. However, the high-end industrial systems represent a significant capital investment, often reach like $1 million. Let's look at the electron beam melting. ABM is used a high power electron beam in high vacuum environment. This is critical for reactive metals like titanium. It's also remarkably efficiency, reaching up to percent 95 energy absorption. Let's look at the binder jet printing. It shows us at the sixth step, as you can see here. At the first step, the roller spreads the powder. As you can see, roller here spread the powder. And then at the second step, the print had just a liquid binder, as you can see here. And at the third step, the platform going to lower here. At the fourth step here, a new layer is sprayed. At the fifth step, the cycle repeats for the entire volume. Finally, the parts is removed because not heat is used during the printing. There is zero thermal distortion. BGP parts are initially green and porous. To reach full strength, we perform sintering to fuse particles and infiltration, where a lower melting alloy is wicked into the pores through capillary action to achieve full density. Let's look at the laminated object manufacturing. Let's look at the figure at the right side. As you can see here, this is a complex turbine prototype in an LOM. A laser cuts the sheets profiles and the heated rollers bond them using pressure sensitive adhesives. As you can see here, it's a most cost effective way to create large scale volumetric models like the one shown here. In summary, as you can see at the table, CLC is for the self-supporting polymers, and then ABM is for the high purity metals, and then BGP is for speed and the color, as you can see here, and then LOM is for low cost, as you can see here, and then large prototypes. Process selection depends on material properties, tolerance requirements. As you can see at the table, you can choose which one is the most useful for you. Thanks for listening. If you have questions, you can text from the comments. I will ask. Here's my references. Kalpakan is our book. I use this article for searching, and then I use Google Images too. Have a nice day.